We have our bag of potato chips. Contains 2 liters of air when it is sealed at sea level at a pressure of 1 atm and a temperature of 20 degrees Celsius. What will be the volume of air in the bag if you take it with you, still sealed, to the mountains where the temperature is 7 degrees Celsius and atmospheric pressure is 0.691 atms? We can assume it's an adiabatic process. What is staying constant as we take the bag from sea level to this new altitude?
Number of moles.
The number of moles. It's sealed, so we're assuming no more air can enter or leave. So we have an isostuff process. Now you can either use the ideal gas law and solve for number of moles and use the ideal gas law again. That's perfectly fine. Or you can use our relationship where P1 V1 over T1 has to equal P2 V2 over T2. That's just, we derive this using the ideal gas law. PV over T would equal NR, N and R are constants, so PV over T has to be constant. So we're looking for, what are we looking for? What will be the volume? So V2. V2, if we bring the T2 over and the P2 down, we can solve for V2. Now, in terms of using this in relating pressures at 2 points and volumes at 2 points, to convert from ATM to pascals, you just multiply by 101, 300. If you did that both top and bottom, the conversion will cancel. You can leave the pressure in ATMs, that's fine. Volume, whatever volume unit you use on this side will be the answer unit on the units on our answers. Temperature, on the other hand, you cannot leave temperature in Celsius. You must convert it to Kelvin. And that's because the conversion between Celsius and Kelvin is an addition. 7 degrees Celsius over 20 degrees Celsius is not the same as 7 degrees Celsius plus 273 over 20 plus 273. The 273s will cancel if you're adding them. So you must have your temperatures in Kelvin. There's no exception to that rule. So P1 we can leave in ATMs, that's fine. V1, 2 liters. T2, 7 degrees Celsius plus 273, 280 Kelvin. T1 is 20 degrees Celsius plus 273, so 293 Kelvin. P2 is the 0.691 ATM. Plugging that all through, you get 2.8 liters. Now, if you did convert to meters cubed, that's fine. This is the same thing as 0.0028 meters cubed. I didn't specify which units to put your answer in, so I'll accept either one.